In this video, I'm going to walk you through an exam question that is really aimed at the A-star candidates in an A-level exam. However, it's not as difficult as it seems. It requires a little bit of logic and some clear thinking, and we can figure our way through this. So I'm going to show you how to tackle this type of question. So let's start by having a look. We have got 6.75 grams of thionyl chloride, that's the SOCl2, placed it in a 2 decimeter cubed vessel, sealed, heated. At equilibrium, number of moles of sulfur dioxide is given. Calculate the equilibrium constant for this system. Before we write an expression, let's figure out what we know and what we need to know. So I'm going to write this out again. This equation. I suggest that in these sorts of questions you do the same, because setting out your work so you can see exactly what we know and what we don't know makes it much easier to jump from one step to the next. Okay, so I'm going to have 2 rows. Initial number of moles. So we're just working in moles now, not in concentrations yet. We'll get to that bit later. So our initial number of moles, well, I know how much SOCl2 was placed into my vessel. It was 6.75 grams. So I know that number of moles equals mass over molar mass. So I can figure out the number of moles that we started with. It's 6.75. The molar mass for thionyl chloride is 135 grams per mole, and that comes out at 0.05 mole. So my initial number of moles is 0.05. And when it's first placed into the tube, the forward reaction hasn't even started, so I know initially I will have no moles of chlorine and no moles of sulfur dioxide. Okay. What about the number of moles at equilibrium? Well, I have no idea. I do know the number of moles of sulfur dioxide. It is 0.0345, which means, if we look at our equation, my products are produced in a 1-to-1 ratio. So if at equilibrium I have got 1 mole of sulfur dioxide, I'd have 1 mole of chlorine. If I've got 0.0345 moles of sulfur dioxide, I would also have 0.0345 moles of chlorine. Now, once again, looking at ratios, let me just clear that out of my way. The ratio of SOCl2, the thionyl chloride, to either the chlorine or the sulfur dioxide, it doesn't matter which, is also 1-to-1. I know how many moles of thionyl chloride I started with, and I know how many moles of sulfur dioxide, for example, it could be the chlorine, it doesn't matter which one we take, we make. So to work out the number of moles of equilibrium, it must be 0.05 moles, take away 0.0345, which equals 0.0155. These are the number of moles, so the next step is to work out the concentration of each of them, and concentration equals moles divided by volume. We know the total volume of the vessel, it's already in decimeters, so we just need to divide each of these by 2 to work out the concentration. So we're going to divide each by 2. So our, what are we going to call this? My equilibrium concentration for each of these, 0.00775. And I'm going to put the units in so we're clear, mole per decimeter cubed, and each of these is 0.0173 mole per decimeter cubed. So now we have our concentrations and we can plug it into our expression for Kc. So Kc, and if you remember, we have yet to write that. Let's write that down. So Kc equals, it is products over reactants, Cl2 gas, SO2 gas over our thionyl chloride, so SOCl2. So that is going to equal 0.0173 squared divided by 0.00775, and it comes out to be 0.0386. In terms of units, I've got mole per decimeter cubed, those two would cancel, so I've just got 1 mole per decimeter cubed left. So the units are straightforward. So the final answer is 0.0386 mole per decimeter cubed. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the blurb below, it will take you straight to the Crunch Chemistry School, where you'll find all the resources you need to get that A-star grade at A-level. Together we can do this.